chapter 4, carbon and its compounds. Okay, carbon is very important element as it has a large number of compounds. Okay, so all the major things which we use are made up of carbon. Okay, like in our daily life, our food, grains, pulses, sugar, tea, coffee, fruits, vegetables are all carbon compounds. The material like cotton, silk, wool, nylon, polyester, they are also of carbon compounds. Fuels like wood, coal, kerosene, LPG, natural gas, CNG, petrol, diesel, even whatever we use for cooking food and running vehicles, all these fuels are also carbon compounds. Rubber, paper, plastic, leather, drugs and dyes, these are all carbon compounds. So you can imagine a carbon element plays a very important role in our daily life. Okay, if we want to test whether there is a presence of carbon in any substance or not, we can just burn it in air, and if it gives the gas, if we pass that gas, it like after burning some gas will be released. If you pass that gas through lime water, it will turn it milky. That this is the proof that carbon exists in that compound. Okay, now, so actually first activity 4.1 is just like simple real something practical which you can do, but it's not much importance. You have to just make a list of 10 things that you use and consume since morning, and just think that what is it made up of. So basically they just want to make you realize that carbon has very important role. Okay, now food, clothes, medicine, books and many other things that are all based on this versatile element carbon. Versatile means it can take many forms. Okay, now the earth crust has only 0.2% carbon. Okay, from all the minerals only 0.2% carbon, and atmosphere has only 0.03% carbon dioxide. Okay, so even its presence is very less, still the compounds formed by it are so large. Okay, now bonding. So what type of bond is formed by carbon? The covalent bond is formed by carbon. So we have seen ionic bond in class 9th also, and in chapter 1 also, when we have seen chemical compounds, the bonds which were formed were ionic bonds. In ionic bonds, there is transfer of electrons from metal to non-metal, or from one element to another polyatomic ion. There is basically the bond which is formed because of transfer of electrons is called ionic bond. Carbon, okay, it forms covalent bond, and we are going to discuss now covalent bonds in detail. Covalent bonds are formed because of sharing of electrons. So in order to make it clear, first of all, I'll take one example of ionic bond like NaCl. NaCl में sodium, atomic number of sodium is 11, so its electronic configuration is 281. Chlorine, atomic number is 17, so its electronic configuration is 287. So whenever sodium and chlorine, they come together, there is transfer of this electron. Sodium always wants to lose this electron, and chlorine always wants to gain one electron to achieve a stable state. So sodium ion is formed and chlorine ion is formed this way by transfer of these electrons. So this type of bonds are ionic bonds. Okay. Now in covalent bond, there is sharing of electrons. So first of all, we will see the atomic number. Anybody knows what is atomic number of carbon?
Ma'am, 6.
Carbon has atomic number 6. So its electronic configuration is 2, 4. Okay. So it has 4 electrons in its outermost shell. Okay. So if any atom has 4 electrons in its outermost shell, it is not possible for it to gain 4 electrons, and rather to lose 4 electrons. Okay, when there is 1 electron short, it's easy to gain. When there is 1 electron extra, it's easy to give. But when there are 4, it's not possible to give and take. So this type of atoms which has like half filled shell, outermost shell is half filled. In this type of case, there is sharing of electrons. Now we'll take one example of sharing of electrons to make this concept also clear. Carbon has 4 electrons in its outermost shell. So I am representing by dots 1, 2, 3 and 4. Okay. Now when it forms a methane molecule, hydrogen has also 1 electron in its outermost shell. Okay. Now for hydrogen to achieve a stable state.
Do you have writing on?
Yes, I am showing on screen.
Ma'am, are you writing on screen?
Yes. Are you not able to see? Okay, what about others?
No, ma'am, it's visible.
It's
Ma'am,
visible.
it's visible.
Okay. So, okay, Nirviksha, you can log out and then log in again.
Okay, ma'am.
Now, so carbon, which has 4 electrons in its outermost shell, and hydrogen which has 1 electron in all. For hydrogen to achieve a stable state, it has to make 2. उसको 2 इलेक्ट्रॉन्स चाहिए स्टेबल स्टेट के लिए, क्योंकि इनर मोस्ट जो शेल होती है उसमें 2 स्टेबल स्टेट के लिए 2 इलेक्ट्रॉन्स चाहिए, उसके बाद 8 चाहिए. ओके, सो दिस वे. तो व्हाट हैपेंस, हाइड्रोजन ऑफर्स दिस इलेक्ट्रॉन फॉर शेयरिंग, कार्बन ऑफर्स दिस इलेक्ट्रॉन फॉर शेयरिंग एंड दे बोथ शेयर दिस इलेक्ट्रॉन. अब शेयर करते हैं मतलब क्या, जब हाइड्रोजन अपने काउंट करेगा तब वो कार्बन का भी करेगा, और जब कार्बन अपना काउंट करेगा वो हाइड्रोजन का भी करेगा. ठीक है, तो ये हाइड्रोजन, एवरी हाइड्रोजन इज ऑफरिंग 1 इलेक्ट्रॉन फॉर शेयरिंग एंड कार्बन इज ऑल्सो ऑफरिंग इट्स 4 electrons for sharing with 4 different hydrogen atoms. Now when carbon will count its atoms, its electrons, it will count this way. तो अब हाइड्रोजन के पास 2, this hydrogen is having 2, this hydrogen is also having 2, this hydrogen is also having 2, and this hydrogen is also having 2, and this carbon is having 1, 2, 3, 4, 5, 6 and 7, 8. This type of bond which is formed is called covalent bond. So covalent bond is formed, carbon, actually most of the compounds which are formed by carbon are formed by covalent bond only. Okay, अब अगर कार्बन सिर्फ 1 इलेक्ट्रॉन ऑफर करता है शेयरिंग के लिए, तो and hydrogen is also offering 1 electron for sharing, then that is actually single bond between carbon and hydrogen. This is single bond. So when I refer the structure of carbon, I represent it by single dash. It is actually the single bond between carbon and hydrogen. Okay. So ionic compounds have high melting point and boiling point. They conduct electricity in molten state. Okay. Now we'll see the properties of some of the carbon compounds. So actually some of the carbon compounds are taken. These are acetic acid, chloroform, ethanol, methane, and their melting and boiling point are written here. Okay, so what happens, actually the boiling and melting point of, they have low melting and boiling point as compared to ionic compounds. Okay, so and they do not conduct electricity. These compounds are non-conductor of electricity. Okay, because anything which conducts electricity is because of forming of bonds, okay, in molten state, but in this case bonds are forming of ions, sorry, and ions in this case are not formed. जैसे अल्कोहल का एक्सपेरिमेंट भी देखा था एक हमने एसिड बेसिस एंड सॉल्ट्स में, कि अल्कोहल डू नॉट कंडक्ट इलेक्ट्रिसिटी बिकॉज इट डज नॉट डिसोसिएट इनटू आयंस. Okay, so the reason is they do not dissociate into ions because they are bounded by covalent bond. Okay, now atomic number of carbon is 6. Okay, so electronic configuration will be 2,4. Okay, so now it could gain actually carbon can get 4 electrons, carbon can lose 4 electrons, but it is not actually possible. So if it were to gain or lose electrons, it could gain 4 electrons forming C4 minus anion, but it would be difficult for the nucleus with 6 protons to hold 10 electrons. And similarly, it could lose 4 electrons forming C4 plus ions, but it would require a large amount of energy to remove 4 electrons. Therefore, carbon do not form ionic bond. Okay. Now, this problem is overcome by sharing its valence electron, and therefore it forms covalent bond actually. Okay. Now, we'll discuss covalent bond in detail now. So let us see the bond formation in case of hydrogen molecule. Okay. अब हाइड्रोजन का एटॉमिक नंबर होता है 1. Okay. So suppose 2 hydrogen are there. Okay. So to achieve stable, nearest stable configuration, hydrogen wants to get 2. Okay. So both of them offer 1 electron for sharing. जो एक इलेक्ट्रॉन है इनके पास, वो दोनों उसी को शेयरिंग के लिए ऑफर करते हैं. Okay. So because of that, how many electrons are shared? Only one. So hydrogen is single bond, and now both of them count. ये जब हाइड्रोजन ये वाला काउंट करेगा तो ये इसके 2 इलेक्ट्रॉन्स काउंट करेगा. ये हाइड्रोजन जब काउंट करेगा तो ये भी इसके 2 इलेक्ट्रॉन्स काउंट करेगा. So this way both of them achieve the stable configuration. Now, in case of oxygen, what is atomic number of oxygen?
12.
12. Atomic number of
8.
oxygen 8. तो इसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन होता है 2,6. ओके. तो आउटर मोस्ट शेल में है 6 इलेक्ट्रॉन्स. तो ऑक्सीजन, सपोज 2 ऑक्सीजन आर देयर, ईच ऑफ देम इज हैविंग 6 इलेक्ट्रॉन्स. इनको दोनों को कितने इलेक्ट्रॉन्स चाहिए आउटर मोस्ट शेल कंप्लीट करने के लिए? 2 इलेक्ट्रॉन्स. सो बोथ ऑफ देम विल ऑफर 2 electrons for sharing. ये बोल रहा है ये दोनों शेयर करेगा. This is offering this 2 for sharing. Okay. So when they will share 2 electrons, this oxygen will count now this 2 electrons also, and this oxygen will count this 2 electrons also. तो इन दोनों ने कितने electrons share किए? 2 electrons. So oxygen will be a double bond. This way we'll write it double bond. So now, is it clear?
Yes, ma'am.
Yes, ma'am.
Okay. तो अब जब ये इसका काउंट करेगा 1, 2, 3, 4, 5, 6, 7 and 8. When the other one will count 1, 2, 3, 4, 5, 6, 7 and 8. Okay. Now, nitrogen. What is the atomic number of nitrogen?
14.
7.
Atomic number is
7.
7. Okay.
7.
So its electronic configuration is 2,5. Okay. Now, when 2 nitrogen, जब इसके पास आउटर मोस्ट में 5 है तो इसको 3 और चाहिए. तो both of them will offer 3 electrons for sharing. Okay. 3 they will offer for sharing. उसके अलावा इनके पास 5 ऑलरेडी है, तो मतलब दोनों के पास 5 है, लेकिन 3 ये शेयर करेंगे. अब जब ये वाला नाइट्रोजन काउंट करेगा तो ये इसके भी 3 काउंट करेगा, और जब ये नाइट्रोजन काउंट करेगा तो इसके भी 3 काउंट करेगा. तो दोनों ने अगर 3 इलेक्ट्रॉन शेयर किए तो नाइट्रोजन और नाइट्रोजन के बीच में ट्रिपल बॉन्ड होगा. इसको बोलते हैं ट्रिपल बॉन्ड. ओके. एंड हाउ मेनी इलेक्ट्रॉन्स दे आर शेयरिंग? 3 इलेक्ट्रॉन्स. ओके. नाउ, is it clear now, Harini? You got the answer for the question also?
Yes, ma'am.
Okay. Now coming to book, let us underline some points. Okay. So what I have explained, this is given in these pages. Okay. One minute. The shared pair of electrons is said to constitute a single covalent bond between 2 hydrogen atoms. Single covalent bond is also represented by a line between the two atoms as shown in the figure. Okay. So if you are asked to explain the single covalent bond or how is a hydrogen molecule formed, you have to make this figure also. Okay. Now, in case of hydrogen, we see the formation of double bond between the two oxygen atoms. This is because an atom of oxygen has 6 electrons in its L shell and it requires 2 more electrons to complete its octet. So each atom of oxygen shares 2 electrons with another atom of oxygen. Okay. The 2 electrons contributed by each oxygen atom give rise to 2 shared pair of electrons. This is said to constitute a double bond between the two atoms. And if you are asked to explain this oxygen, you have to make this figure also. Actually, figure gives additional information plus like it adds on you are basically a person who checks feels that a student can explain and knows better. So always draw a figure wherever it is possible. Okay. Now, nitrogen has atomic number 7. So electronic configuration, now this is the nitrogen molecule. Here triple bond is formed. Okay. So this is said to constitute a triple bond between two atoms. An electron dot structure of nitrogen and its triple bond is depicted in the figure. Okay. Now you can draw some more structures also. Okay. So so chlorine, atomic number of chlorine is 17. So its electronic configuration will be 287. Okay. So chlorine has 7 electrons in its outermost shell. Okay. अब इसको कितने और चाहिए? It needs 1. दोनों ही क्लोरीन को they need 1 electron. Okay. Whenever दोनों साइड को ही अगर कुछ रिक्वायरमेंट है, एक्सेस नहीं है, तो ही कोवेलेंट बॉन्ड फॉर्म होता है. तो 1 2 3 4 5 6 7 1 2 3 4 5 6 7 both of them will offer 1 electron for sharing, क्योंकि दोनों के पास दोनों को एक एक की रिक्वायरमेंट है. So when it will count this one also. When this will count, it will count this one also. So chlorine will be a single bond. Okay, we'll discuss the molecule of ammonia, that is NH3. So NH3 nitrogen has 7 electrons in total. Atomic number is 7. Electronic configuration is 2, 5. So 5 electron in its outermost shell. It needs 3 electrons. Okay. So 2 electrons. It needs 3 more electrons. Okay. And hydrogen, which has only 1 electron. All of them need 1 more electron to achieve nearest noble gas configuration. So each of this hydrogen will share 1 electron with nitrogen. Now when nitrogen will make its count, it will count all of these electrons. And when hydrogen will count, it will also count 1 electron of nitrogen also. So now each nitrogen has 1 2 3 4 5 6 7 and 8. Okay. And each hydrogen has 2 2 and 2. So when we'll draw its structure, it is NH3. This is the structure. Single bond between each nitrogen and hydrogen. Carbon shares its electrons with 4 atoms of hydrogen as shown in the figure 4.5. So we have already discussed this structure of methane before. Okay. So this is given here. Okay. This is electron dot. This is called electron dot structure of methane. Okay. जब ये इलेक्ट्रॉन्स आउटर मोस्ट शेल के इलेक्ट्रॉन्स को ड्रॉ करते हैं डॉट या क्रॉस के फॉर्म में, इसको इलेक्ट्रॉन डॉट स्ट्रक्चर बोलते हैं. नाउ
Ma'am.
Yes.
Ma'am, why?
Such bonds which are formed by sharing of electron pair between two atoms are called covalent bonds. Okay. Covalently bonded molecules are seen to have strong bonds within the molecule, but the intermolecular forces are weak. Okay, this gives rise to low melting point and boiling point of these compounds. Since electrons are shared between the atoms, no charged particles are formed. Such covalent compounds are poor conductors of electricity. So these are all properties of covalent compounds. Okay. Now, allotropes of carbon. So there are 3 allotropes of carbon. 2 are very popular, which all of you know, diamond and graphite. And next is one more is there. It is called Buckminster fullerene. Okay. Now the element compound occurs in different forms in nature with widely varying physical properties. Both diamond and graphite are formed by carbon atoms, but difference lies in the manner in which the carbon atoms are bounded to each other. In diamond, each carbon is bounded to 4 other carbon atoms, forming a rigid 3-dimensional structure. And in graphite, each carbon is bounded to 3 other carbon atoms, giving a hexagonal structure. तो actually diamond में जो bonding होती है वो ऐसी होती है कि none of the arm of carbon is free. Basically carbon has 4 arms. All are tightly packed. Okay. But in graphite, 3 sides are tightly packed and 1 side is free. Therefore, graphite conducts electricity, but diamond do not conduct electricity. Now, actually, this meeting is going to end, so let us reconnect.